In this video, we are going to start the final exam review part 1. Now, we're going to do 20 questions in this first video, and then we'll do the next 20 questions in the next video. Expect most likely 4 final exam review videos. It is probably essential that you start now because the final exam covers everything that you have done in the course for the entire year. You can have some of those papers we have made up for our other exams, but you might want to put everything on one sheet of paper to kind of condense it as you go. Okay, so let's take a look at our first problem. It says a mountain climber hikes with 2 friends for 5 hours. Identify each phrase as defining a quantity with a fixed value, a quantity that varies in value, or not a quantity. So the total number of miles that the friends hiked in 5 hours would be something that varies in time. As they walk, they're going to be walking more miles, and so that total number of miles would be a quantity, and it varies. The friends themselves are not a quantity. If they said the number of friends, it might be a quantity. The number of hours elapsed is going to change over time, so that is a quantity that varies. The number of hikers is a quantity, but it has a fixed value. There's always 2 hikers. The number of miles that the friends have hiked since they started, that is something that is going to vary. And so that is a quantity that varies. A mountain climber hikes with 2 friends for 5 hours. Identify each phrase. The total number of miles that they hike in 5 hours. I guess once that has been established, it never changes. At 5 hours, they're at a certain spot. So I'm sorry, let's change that one to a quantity with a fixed value. Okay, there we go. Let's move on to question number 2. It says, when you eat, stomach breaks down your food into glucose and raw materials such as minerals, fatty acids. And the following graph represents an individual's blood glucose level in terms of the hours since they ate. So you'll see that if you eat a complex carbohydrate, it has a slightly different glucose level. It hits that highest level at 1 hour. But if you eat a protein, it hits it at about 2 hours. Okay, so that's kind of the breakdown of what that chart is doing, and then it kind of evens off. So always when you're looking at a chart, always check out what do the axes say. So like, you'll see that number of hours elapsed since eating is along your x-axis. Your glucose level is along your y-axis. So always kind of check how the axes are counting. You'll see that's by quarter hours at the bottom, and it's by milligrams of glucose per liter of blood. And so that's counting by 25, so 850, 875, 900, 925, 950. So you always kind of want to look at that first. And your first question says, as the number of hours since an individual ate a complex carbohydrate, so we're looking at the red graph, from half to 1, how does the blood glucose level measured in milligrams of glucose per liter of blood change? So you'll see how if we were to graph just that little section of the graph, that function it's still increasing from a half to 1. It's going uphill. And if we check out what it's going at, I think that it is about at 1,000 milligrams per liter of blood. And then if we go and we check what it's at 1, it has gone up to 1,100 milligrams. So it increases from 1,000 to 1,100. Now I'm going to just submit just to make sure I didn't do anything silly. Okay, so now we're moving on to the chart about protein. So we're looking at the black one. And so our black chart there, it says what's happening from 2 to 2.75. So at 2, I believe we are up here at 1100. And then at 2.75, so that's exactly between 2.5 and 3, it looks like we're at 1025. So you'll see that from our initial starting point, 1100, then we went down. So this time we are decreasing from 1100 to 1025. I'm just going to hit that, okay? Okay, so now let's look at part C. It says after Jake ate a bagel, which is a complex carbohydrate. So we're looking at our red chart. He noticed his blood glucose level decreased from 1,000 milligrams to 900. How many hours elapsed between these readings? So we're just going to find those on our chart. So let me erase what I had written down here. Okay, so it's decreasing over that hour time, or over that time period. So let's look on the side of the graph that's going downhill from 1,000 to 900. Okay, so let's take a look. So if we look on the carbohydrate, it on the downside side of the graph, right here is where it's at 1,000, and you'll notice that 1,000 mark is at the 1.5 hour mark. Okay, now so that's there at 1,000. Okay, so 900 looks like it hits. It doesn't quite hit at anything good. It's kind of about right here. And I'm going to guesstimate that it seems to be not quite at 2.125. 2.25. It kind of looks right in between 2 and 2.25. So the average of 2 and 2.25 is 2.125. So I'm going to put 2.125. Okay. And so how much time elapsed for 1.5 to 2.25? 2.125. So if you take 2.125 minus 1.5, that is a change in 0.625 hours. So I think that it is 0.625. And they would probably give you some wiggle room since it didn't hit a beautiful, lovely point. Okay, so that is a little about reading a graph and what side's increasing, what side's decreasing. Is it going uphill, downhill, things like that. So that's question number 2. Let's jump to question 3. Suppose that a constant rate of change of a y with respect to x is 3. So that means that delta y over delta x is 3. They're telling us that our slope is 3. So the change of the value of y is 3 times as large as the change in the value of the x. Yeah, because we can think about that as 3 over 1, so I agree with that first statement. The value of y, now not the y, but the change in y, so we can't say that that second one is true. The change of the value x is 3 times as large. No. So that one's out. Y equals 3x? Nope. If we solve delta y over delta x equals 3 and we cross multiply, we get delta y, is 3 times delta x. It has to have that delta in there. They're only telling you about the change, not the true equation. So it would be this one. And then that's the only two that really mentions the change in and the slope. So that's question 3. Let's move on to question 4. So we have 2 points. What is the constant rate of change? Now, if we have 2 points, remember our delta y over delta x is just our change in y, so y2 minus y1 over x2 minus x1. Now, it really doesn't matter which one you call x2 and x1 or y2 and y1, as long as you're consistent. I look at the x's and go from least to greatest. It does kind of help it work out a little nicer, but it's, again, no big deal. So we're going to call our negative 1, 1. We're going to call that x1, y1, and we're going to call 5, 25. We're going to call that x2, y2. So make sure you know your slope equation. And when we do that, the change in y over the change in x for these two quantities, it's going to be 25 minus 1 over 5 plus 1, which is 24 over 6, or 4. So that's the answer for the constant rate of change with y respect to x. So the formula, remember, we have that formula. Write a formula to express delta y in terms of delta x. If we just cross multiply, delta y is 4 times delta x. And that's all they want there. For delta, I'm just going to type in delta. So delta y equals 4 times delta x. I'm going to check my preview. Is the preview what I want it to be? Yes. So that looks good. And then it says write a formula that expresses y in terms of x. So now you need to use a different formula. Let me remind you that formula is y minus y1 equals m times x minus x1. Okay, so how can we deal with that? So our m is going to be the 4 we found. So that's going to go right there. Our x1, y1, we already labeled, and that's going to go here and here. So let's plot that into our formula. I think we could probably, well, it says write the formula with y in terms of x, so we will have to solve for y. So we're going to get y minus 1 equals 4 times x plus 1. You'll notice that this is the opposite of y1. It was 1, now it's minus 1. This is the opposite of x1. That's minus 1 became plus 1. And now let's make that pretty. So y minus 1, let's distribute 4x plus 4. Move the negative 1 over by adding 1, and we get y equals 4x plus 5. So they just want the equation of the line. Now that we've got that, when the value of y when x is 104, we're just going to take out our x, and we're going to replace that with 104. So it's just a substitution. So y equals 4 times 104 plus 5. Since they already have that y equals, I think we could probably just put in 4 times 104 plus 5. But let's check and make sure I didn't make a silly mistake along the way. There you go. So that's how we use the slope equation for our delta y over delta x. That's how we use our point slope to find the equation of our line. That's our formula. And then once we have a formula, we can plug in whatever they ask us to do. So that is question number 4. We're going to do the same thing for question 5. So I am going to leave that to you. It's exactly the same way that question 4 was. Let's look at question 6. It says, let me kind of scooch it out here so we can make it a little bigger. Linda is riding her bike to the restaurant. She rides at a constant rate of speed of 31 feet per second. So I know that the delta y over the delta x is, or her slope is 31 feet per second. So that kind of gives me some clues here. I know my y is going to be in terms of feet. I know my x is going to be in terms of seconds. The restaurant is 649 feet from her house. So I'm going to put a little house here and a little r, h for house and r for restaurant. We know that that distance is 6,409 feet. See how we were in a rate of change of feet. And that says let t represent the number of seconds since Linda has left her house. So let's make ourselves a little note that t is seconds and that d be the distance from her house. That would be in feet. Distance, oh, I'm sorry, from the restaurant. So I'm going to make a little line here. Wherever she happens to be, that's D. Okay. So let's think about what we know, okay? We know from what I've written down that it's 31 feet per second. So the 31 represents how many feet she travels in 1 second. So that would be E. So we know that that was our feet per second. Okay. Now, if we take the total distance and we divide by that rate, 31, distance equals rate times time. So I know that the distance is 31 times t. I see 31t there. That 31t then is the total distance that she is away from the restaurant. Let's see. Wait a second. That wouldn't be the same d as that one. Let's see how we could write it so that, okay. So that's how many feet she has ridden. So d would equal the distance from the restaurant minus off the 31t. So that's the top one there. That is the total distance that, so if we took off, that is how much she has, that 31t is here. Let's put, that's 31t. So we know that so 6,409 minus 31t is the distance she has left to go. So that's the distance to the restaurant. So the distance to the restaurant. Okay, so that's F. So it's just kind of organizing what you know and then linking it all up. T is the number of seconds she has ridden. So where is that one? Number of seconds since she left her house. That's A. We already know 31 is her rate, what she would ride in a second. 6,409 divided by 31 would be the time it takes her to get to the restaurant. So it says the time to ride to the restaurant, that's D. And then 31t is just how far away she is from her house. So that would be B. So I think we got everything accounted for. Write a formula that determines the number of seconds that gives the distance from the restaurant. And so see how we said the distance from the restaurant is that F, that top formula. So 6,409 minus 31t. Oh, we want the whole thing. So I think we should probably put that D equals 6,409 minus 31t, not t squared. So let's submit it. Let's see what they say. So there you go. So expect that we've seen this one when we did a test earlier in the year. Okay, let's look now at 7. Okay, similar but a little different thinking. So let's do this one. Okay, define a formula to express n, Lisa's distance in feet from the park bench. So you'll see that she's traveling 325 feet per minute, and she is started going at 7 o'clock. If n is the distance in feet she has walked and t is in minutes, we know distance so express the formula n, so that's her distance, is going to be 325, no, I'm sorry, the total, it's kind of think of like the last one, the 1850 minus off what she's walked, so 325t. Okay, now Sarah's distance from the park bench is going to be m, and that's going to be, she only has 1430 to go, minus her rate, 315t. Okay, let's check those before we go further, just to make sure that I didn't miss anything. Okay, so we got those. So now we have a formula for the distance that it's going to take Lisa to get to the bench and Sarah to get to the bench. And it says define a formula D that would be the distance between them. Okay, so if A is given the distance that she has to go to the bench and B is given the formula that she has to go to the bench, it would be the total of those two things would be how far apart are they? How far apart are they before they get to the bench? And I like that each time is 7 o'clock, so they're leaving exactly the same time. We don't have to mess up the minutes at all. So the distance is going to be the total of those things. So 1850 minus 325t plus 1430 minus 315t. Now I'm not going to simplify it because I don't want to mess it up. I know my first two are okay, and so then I'm going to submit them. So there you go. There is question number 7. Let's look at question 8. Now question 8 is almost like one we had done earlier, so that's your responsibility. Let's take a look at question 9. We're given a distance formula that's traveled by a car moving in a straight line is given by the quadratic you see there. T is in seconds, and we got that, okay. So the average speed for the time period from 1 to 7.9 is the slope, the average rate of change between 2 points on a nonlinear function is just, so average rate because it's not linear, we're just going to calculate the dy and the dx at those particular points, okay? So let's take and plug in 1. So I'm going to call it S of t. It's kind of so I have a spot to plug junk in. Okay, so I'm going to make that a 1 to 7.9. Okay, so that's the formula you need. Oh, we know how to do that formula. Let's plug in 1. Let's plug in 7.9. If we plug in 1, we get 2 times 1 squared plus 3 times 1 plus 1 is 6. If we plug in 7.9, we get 149.52. I do like to go from least to greatest. That is helpful. Okay, so our x1, y1 is 1.6. Our x2, y2 is 7.9, 149.52. I'm going to see if iMath will just let them do the math. So my change in y is going to be 149.52 minus 6, which I guess I could have done in my head, 143.52, divided by the change in x, that is 7.9. Okay, so that would be 7.9. The change in x, 7.9 minus 1. So let's see if they like that, or if they are okay with us letting iMath do the work. Yeah, they're good with that. So you're just going to do that again and again for B and C. I'm going to let you do that same formula. For B, you're going to use 1 and 8.7. In C, you're going to use 1 and 5.4. So that's your responsibility. Let's move on to 10. Let's take a look at a circle problem. Now it says a circle is centered at the origin and has a radius of 5. Let me give you the circle formula. So this is something you're definitely going to want to have written down or memorized. So it's x minus h squared plus y minus k squared equals r squared. So in this case, our hk is given to be 0, 0. And we're given that our radius is 5. So if a circle is centered at the origin and has a radius of 5, what's great is it's going to be x minus 0 squared. X minus 0 squared is just x squared. Y minus 0 squared, or y squared, equals 5 squared, or 25. So now we have an equation for our circle. Now I'd like to fill in C, and if you're doing it same and you might have different information, go ahead and plug in the equation of your circle before we answer A or B. Okay, so that's my equation of the circle, and so it's good to go. Okay, so now I have an equation of my circle, and it says which points on the circle have an x-coordinate of 1. A circle usually has 2 corresponding points for every x that are within the domain. So, and since 1 is in the domain, so is 4. That's within that radius of 5. We should get 2 points. let me show you what to do. Once I do A, then it's your responsibility to do B. So we're saying that x has a coordinate of 1. So just take out your x and put in a 1. Now let's go ahead and calculate that. 1 squared is 1. So if we have 1 plus y squared equals 25, that would be that y squared equals 24. So y would equal plus or minus the square root of 24. Now see how it says if you have a list of points, separate them by a comma, you get a plus or minus because the square root of a, when you inflict it, always remember that plus or minus. Okay, so my first point here would be 1 comma the square root of 24. Now, they might not like it because they might want us to simplify that square root. 24 is a square root that can be written as 2 radical 6. Now, I'm going to leave it, I'm going to look at the preview. I see 1 square root of 24, 1 minus square root of 24. So I'm pretty happy with the way it looks. I forgot the comma between them. They might yell at me for that. So let's put a comma between it. And let's submit that. So they didn't put simplified radical form, so I think that's why they accepted it. I'm going to be looking at all of your answers that you input. So, you know, if you had square root of 24, which is correct, I'm going to give it to you. Unless they say simplified radical form, I may actually go ahead and, you know, take off a very little amount if you didn't follow the instructions. Okay, so it's your responsibility to finish up A and B. Let's take a look at question 11. Now, question 11 follows the same sort of thing, except the formula for the circle is a little bit harder. We have a center at 3, 1, and we have a point at negative 4, 3. Okay, so that's you know, kind of where we're at. So I'm going to kind of make this smaller so that we can go ahead and so you can see my work a little nicer. Okay. So we know initially that x minus 3 squared plus y minus 1 squared, use that center, should equal our r squared. You see they didn't give us the r, but we can find the r pretty easily if we just stick the xy that would get out to that radius right there. Okay, so let's go ahead and stick it, excuse me, our negative 4, 3. So negative 4 minus 3 is negative 7. So I just kind of did that for you there. This is 3 minus 1, which is 2. Okay, negative 7 squared is 49. 2 squared is 4. 49 plus 4 is 53. So r is the square root of 53. Now we don't need the plus or minus there because a radius is a length, so you don't need a plus or minus in that case. It doesn't hurt anything. So that's our radius. So that's what they're looking for here. 53 cannot be reduced any. So the square root of 53, if I could type, is all we need there. Okay. Okay, so we got that. I'm just going to submit it. Make sure you're right before you move on to the next one. So now we can write our equation. So we're going to go back to this step right here, except we're going to put a square root of 53, but when you square root of 53, remember r squared is 53. So we don't have to put any square roots. It won't hurt it, but x minus 3 squared plus y minus 1 squared should equal the square root of 53 squared, which is just plain old 53. I like looking at the preview, making sure it looks the way I want it, and then you got to submit that. So there is another circle question for you, question 11. Let's look at question 12. Okay, It says suppose function k gives the volume of water in a pool in terms of the number of minutes. Which of the following represents the volume of water in the pool 34 minutes after you've filled it up? Well, our function is k, so our function k is given by the volume after 34 minutes would be k, the function k, if I plug in 34. So that was not a bad question. Let's look at question 13. Now we're going to use a graph. Remember, the g of is just saying what is the height when your x is that number. So if we look, I'm just going to do a few of these for you. When x is -2, if you look right here, and I'm sorry I can't really write on the graph, you're looking for what is the height. So, you know, if you go to where -2 is and you look at that height, you'll see it hits 1 perfectly. So when x is -2, my height is 1. Excuse me. Now, when x is -1, I'm at a height of 3. And I'll do one more for you. When x is 3, I'm at a height of 3. So that's all they're looking for there. And you can check a few before you move on to the final one. Make sure you're thinking about that, right? So that g of -2, if my x is -2, what is my height? Let's talk about the domain of rational functions and fractions. So the rule that you want to remember for domain, I'm going to write out a little cheat sheet information for you. If it's a polynomial, the domain is all real numbers, so nothing messes that up. If you have a rational function, just set the bottom equal to 0 and you want to skip them. If you have a square root, you want to set the inside of your square root greater than or equal to 0. Okay. C is a combination of those rules. So you're just going to set the inside equal to 0, solve for that value. That's the one we have to skip. So you go from -infinity to that value. You're going to skip it. If there's more than one value, just keep skipping and skipping, skipping, you know. So it's -infinity to 3. I got to skip it. And then go from 3 to infinity. So to make an infinity symbol, you can just hit OO. To make that union symbol, it's just a capital U. My preview looks really good, so I think we're good to go. Okay. Now, if we go to B, remember for a square root, we're going to set the inside greater than or equal to 0, and we're going to see what the heck happens. Only thing is if you divide by negative, flip the symbol, otherwise we're good. So that's greater than or equal to -7. So our domain for this one, I have to include -7 and I can keep going. So from -7 to infinity. So I'm going to put a bracket on my -7, comma, OO for my infinity symbol. Infinities always get a parenthesis. Now C is the hardest one. It's a combination of those things. X minus 4 is in our denominator. We have to skip 4. So that is something we will skip. But we do the same thing to the top square root. X plus 39 is greater than or equal to 0. So X is greater than or equal to -39. Now, -39, we can usually go from -39 to infinity, but we have to skip 4 because 4 messes that up. So how do we do that? So normally we'd go -39 to infinity, but we're going to get a problem at 4. There's an asymptote there. So we're going to skip over 4, but then we can keep on going. So we're going to have a bracket on our -39. We're going to go to 4. We're going to put our union symbol, and then we're going to go from 4 to infinity. So I think we got everything we need for question number 14. Let's go to question 15. So let's talk about question 15. It says P is the cost in dollars to fix a road. Make yourself a little note, sometimes that's helpful. in terms of the number of potholes. So let's call H for potholes. So use function notation to represent the number of dollars needed to fix 6 potholes. So that would be our function P in terms of fixing 6 potholes. If I could plug a 6 in. So I got to plug in 6. Okay. Use function notation to represent the cost to fix a random n potholes. So that's just P of n. Use function notation to represent the change of the, if it goes from 10 to 5. Well, remember, that's just the change in. So we're going to do, that is the P of our ending, P of 15, I'm so sorry, P of 15 minus P of 6. Now I'm going to put that in parentheses, the whole thing, so they know that that's the top of my fraction, divided by, oh, not 15 and 10. This is hot, over 15 minus 10. So it's P of 15 minus P of 10 over 15 minus 10. Look at my preview. Perfect. Okay. Submit all those to make sure we're thinking right. Okay. Wait, what did I do wrong? Use function notation to represent the change in the cost of fixing the road as the number of potholes on the road increases from 10 to 15. Maybe they want this bottom to actually be the number 5. 15 minus 10 is 5. Let's make it a 5. Let's see if they like that. No. Well, here, we'll come back to that. Why did they not like that? Use function notation. Is it called P? Yeah, that was function notation. P of 15 minus P of 10 over 10, 15 minus 10. I have no idea why they don't like that. We'll come back to that one. Not sure. We'll come back. Use function notation to represent that it costs $400 to fix 2 potholes in the road. So I think they would want there that P of 2 equals 400. Now they're going to let me see the answer here. Oh, I'm sorry. So they just wanted the change in the P, not the whole change in P, the average rate of change. I'm so sorry. So they just wanted the P of 15 minus P of 10. Here we go. I was making it more complicated than I had to. You know, I'm good at that. Okay. So there is question 15. Now in this video, we're going to go up to question 20. And then next video, we'll finish this one off. Okay. So we've got this function, f of t, which is representing the number of minutes since the car left the gas station. Okay, so it's distance. And distance in feet that it is away from the car station. So this is in feet. And t is minutes. Okay. So, and what is the meaning of f of 8 minus f of 4.5? So that would be the change in distance. It's not the average speed unless we divide by that, like I was trying to do in that last time. So it is just the number of feet that the car traveled from 4.5 to 8. Okay. Because the f's represent feet, so if you subtract the feet, you're finding the change in feet. What is the average speed? Now here's where we got to do average speed. Anytime they use that word average, we need to do that f of 8 minus f of 4.5 over 8 minus 5. In this case, 1.5 and 3. Okay, so f of 1.5 and f of 3 is what we need. If I plug in 1.5, let me tell you, 0.25 times 1.5 squared plus 6 times 1.5 is 9.5625. Now I'm going to take that all the way out, okay? So that's the point 1.5, 9.5625. Now if I plug in 3, 0.25 times 3 squared plus 6 times 3 is 20.25. So that's the 0.3, 20.25. So now we need the whole average feet per minute. Okay, so if we do the minutes, the feet per minute, I'm sorry, if we do the feet, that is on the top, I'm going to do 20.25 minus 9.5625. That's the feet on top, divided by the minutes. So feet divided by minutes. So 3 minus 1.5. Now, the preview is 7.125, so you could probably put 7.125. But I think it's good, and I think they'll accept it. And they've done that. So these ones are all about your average rate of speed, function notation, things of that sort. Now let's move on to 17. We've got a function, but this time we're looking at a few different things than we had looked at before, but we're still going to pull out the values of our function. So our function is f. It says, what is the value of x such that f of x equals -1? So what we're saying here is we want the x's where the height, the y value, is -1. So if you look right here on our graph, there's where the height is -1. There's only one. It could have multiple. This could have multiple things. But there's only one value of x. I think it's -3. So that would be that one. Okay. So here we're just looking at what is f of 2. So that's a. So b, they're looking at f of 2 minus f of -2. Okay. So if I look at on the graph, what is f of 2? So if I go over to 2, we're at a height of 3. And then if I go over to -2, we're also at a height of 3. So if I subtract f of 2 and f of -2, 3 minus 3 is 0. Okay, and so that's what you do for C. Now, D is different. It's asking for the average rate of change. So C you can do yourself. Let's look at D. So we want the average rate of change as x increases from 2 to 6. So we have to find f of 2 and f of 6. If we go on the graph, f of 2 is at 3. If we go to 6 on the graph, 6 hits a height of 6. So it's just the f of 6 minus f of 2, here we go, over 6 minus 2. So this is just the f value at 6 over 6. This is the f value at 2 over 2. Just that rate of change. And so that would be 3 over 4. So that is how you do 17. Let's go to 18. So f of 3, just plug in 3. F of -11, plug in -11. I would like to do ones that are a little bit funkier. Let's do C and E together, and then the rest you can do yourself. So if we look at C, we are plugging in x plus 2. So we're going to take out the original x's. So you'll notice I've left a little gap where the original x's have originally were sitting. And I'm going to take out that x, and I'm going to input instead x plus 2. So I've just done that. Now, I don't know how much they want us to simplify. So I'm going to try something. I'm going to put in 4 times x plus 2 quantity squared plus 2 times x plus 2 plus 1 plus 6. Let's see if iMath will allow that. Yeah, so you don't have to simplify that out. If it said, excuse me, in fully simplified form, do your thing. But I do want to also do E with you, because it's really easy to make a mistake on that because we're plugging in 2x squared as our input. Now still leave yourself a little bit of room where the original value is sitting. Remember, whatever the input is, it's squared multiplied by 4, and then added with 1 and multiplied by 2, and then plus 6. So it's just the same thing. Just watch the way you enter it. So we're going to put 2x squared in the parentheses. We're going to get 2x squared with the plus 1. So now let's do that one. So 4 times our input, 2x squared, plus 2 times our input, 2x squared, plus 1, plus 6. So you can look then at your preview before you submit. So that is a little bit about 18. Now let's move to 19. 19 is about composition of functions. So let's look at A, where they say G of P of H. Oop. Now, P originally has M's in it. Don't overthink that. Take out the M, input an H. So if we input an H into P, it becomes H plus 6. Now we never have to look at that again. We just have to look at our G function. Now our G function says 3 times the square of our input plus 2 times our input. So now instead of an F, they had F's in there, we're going to put in a H plus 6. And we're going to do like we did the last time when we go to plug that in. So it's going to be 3 times H plus 6 quantity squared plus 2 times H plus 6. Good to go. Okay, well, let's submit just to check our thinking. B, you're inputting 1. So you could put 1 into P, get 7, and then put 7 into our G function where the F's are sitting. Okay. As the value of H increases from 6 to 16, how does the value of G of P of H change? So let's actually do that for 6 and then do for 16, and then let's see what the heck happens, okay? So B, I think you can do yourself. Let's do C. Let's do G of P of 6, and then let's do G of P of 16. So how does it change? Now, if I plug in 6 to P, start from the inside, work your way out. 6 plus 6 is 12. So I'm really just doing G of 12. I'm sorry, let's make that look prettier. So that's just 3 times 12 squared plus 2 times 12. So I'm going to need to put that into a calculator. So that's just 3 times 144 plus 24 is 456. Now let's try with 16. 16 plus 6 is 22, so that's G of 22. So that's 3 times 22 squared plus 2 times 22. What is that equal to? Well, 3 times 22 squared plus 2 times 22 is 1496. Now, do you see how that value went from 456 to 1496? It increased. So we're going to say it increases, and it increases from 456 to 1496. Now, that's if I didn't make any silly mistakes. We should be good to go. And then the last question we're going to do now in this video is 20. Now, we've given an x function, a g function equation, an h function, which is by a table, and then a k function, which is in the graph. Okay, so I need to make that a little bigger so we can really zoom in. Okay, let me say that again. G is the function x plus 5. H is the function in the table. K is the function given by that curve. Okay, so in the first one here, we need to do k of g of 0. Okay, so k of g of 0, we start from the inside, work our way outside. G of 0 is just that g of x equals x plus 5 is just 5. Now, the k function is our graph. So we go to the graph of 5, and you can see that we're a height of 20. So that first one is 20. Now let's look at B. Now B is going to be h of k of 1.5. So if we start at 1.5 on the k, that's our graph, 1.5 hits the height of 6 perfectly. So that is 6. So now we need to use the h function, and if we plug in x of 6 into our h function, we get 15. So that one's 15. So I think that should give you an idea of what to do for A through D. Same thing, just go from the inside out. Okay, now I would like to talk about E. Now E and F are the same kind of thinking. Okay, it says, where would h of g of x equal 3? Now this one's a harder way to think because we have to think about, on the h function, where is the height 3? So if we go to our h function, the only y value I see of 3 is 4. So that means that this inner input had to be 4. So that tells us that g of x is equal to 4. But now we have to calculate backwards to the g function. So my g of x is x plus 5 has to equal 4. So x would have to equal -1. So we have to start from the inside out, and we have to connect it with the y's this time. And so that would be -1. And so that is how you do E and F. So that's your first 20. Expect 3 more videos. Take lots of notes. You've got a lot to study. There you go.